Could you travel faster than light? What if I told you that science is on the verge of ripping up the rule book and making the impossible real? The fastest thing in the universe, light, still takes over 4 years just to reach the nearest star outside our solar system. That means even at light speed, a trip to our cosmic next-door neighbor is longer than a human lifetime. Think about that for a second. Honestly, the more I learn about this, the more I'm convinced our brains just aren't wired to grasp how vast space really is. You could be born, live your entire life, have children, grow old and die, and a photon that left with you would still be wandering through interstellar space, not yet arrived. Physics is being rewritten. Subscribe so you don't miss a beat, and hit that like button if you're ready for the next deep dive. But what if we could smash that limit and travel 10 times faster? Buckle up because science might be about to do just that. Scientists have discovered a method that could let us zoom across the cosmos at speeds 10 times faster than light. What used to sound like pure wizardry, warp drives, hyperspace jumps, has caught serious scientific momentum. Researchers are scrambling to build real prototypes that could slash interstellar travel from centuries down to mere decades. Dinner on a distant star system? Maybe sooner than you think. But hold up before booking that ticket to Alpha Centauri. Since Einstein's 1905 special relativity bombshell, we have been told nothing with mass can break the ultimate speed limit, light speed itself. To get there, you would need infinite energy, basically an impossible fuel tank. Light speed clocks in at a whopping 299,792,458 meters per second, fast enough for sunlight to reach Earth in 8 minutes. Sounds speedy, but on cosmic scales, it is a crawl. Light takes over 4 years to reach our nearest star neighbor, Proxima Centauri, and a staggering 100,000 years to cross the Milky Way. So yeah, with current physics, space travel is a real drag. Here's the twist. New breakthroughs might just rewrite those cosmic rules. Faster than light travel is not just sci-fi anymore. It is gearing up to be science fact. Whoever nails this will be a legend, putting Einstein in their rearview mirror and turning space travel from a slow slog into a warp speed joyride. Let us be real. Space travel right now, it is painfully slow. Even our current record holder, the blazing fast Parker Solar Probe, would need over 70,000 years to reach the nearest star. Yep, you would have to start your journey sometime during the Ice Age to get there today. That cold, hard truth has long smacked us in the face. With today's tech, the stars might as well be postcards from a parallel universe. We are stuck with rockets that crawl compared to the vastness of space. Even our most ambitious propulsion systems cannot shrink interstellar trips into anything remotely close to a human lifespan. For decades, physics has stood firm like an old librarian, guarding the secrets of the universe. No faster than light travel. Thank you very much. But a new generation of scientists is not taking no for an answer. These dreamers, tinkerers, and visionaries are not just gazing at the stars. They are rewriting the rules to reach them. They believe that even the universe's speed limits can be well negotiated. And suddenly, faster than light travel is not just a sci-fi flex. It might actually be necessary for our survival. At first glance, warp drives and space-folding tech sound like something pulled straight from a Star Trek rerun. Fun to imagine, sure, but surely not practical, right? Dig deeper and it becomes clear. If Earth ever turns inhospitable, and let us face it, we are not treating it kindly, there is nowhere else in our solar system fit for human life. Not Mars, not Titan. Nobody wants to live on a frozen desert rock. That is why faster than light travel is not just a wild sci-fi fantasy. It is a potential lifeboat for the human race. Our drive to explore is hardwired into our DNA. From crossing oceans to launching telescopes, humanity has always looked to the horizon. And now that horizon includes alien worlds. Just a few light years away, planets like Proxima Centauri b and those orbiting the TRAPPIST-1 system look tantalizingly Earth-like. But they are so far we might as well be staring at them through a locked window. Faster than light travel would make reaching these places possible. The problem? For most of modern science, going faster than light was about as likely as turning lead into chocolate. The very laws of physics, as laid down by Einstein, have insisted it is a no-go. Trying to accelerate mass to light speed requires infinite energy. Like trying to charge your phone with a lightning bolt, cool in theory, not so much in practice. That is why for years the idea of faster than light was exiled to the fringe. Science fiction, philosophy, or the fever dream of a sleep-deprived physicist. But then someone like Miguel Alcubierre came along, a brilliant mathematician with a Star Trek poster on his wall and a knack for bending equations. Alcubierre proposed a loophole. We might not be able to travel through space faster than light, but maybe, just maybe, we can warp space itself. We have officially entered an era where quantum weirdness is no longer just for whiteboards and wild TED Talks. It is becoming the front line of physics. Classical physics, with all its Newtonian elegance and Einsteinian swagger, is starting to look, well, a bit old school. Today, if you are not talking about antimatter, dark matter, or energy that sounds like it came out of a Marvel movie, you are missing half the story. We are learning that the universe is not just made of balls and levers anymore. It is made of probabilities, shadows of particles, and space-time that can stretch, twist, and maybe even fold like cosmic origami. In this new playground of physics, the old rulebook, especially the one that says nothing with mass can go faster than light, is beginning to fray around the edges. Instead of blasting your spaceship through space like a bullet, some scientists are imagining a totally different trick. Warp the space around it, like pulling the rug beneath your feet instead of walking across the room. Your ship stays cozy and still, and space does all the work. No G-forces smashing you into your seat. No time dilation making your return trip to Earth a 1,000-year reunion. Just a gentle slip through a fold in reality. Crazy, maybe. But the weird part, a lot of this is not just theory anymore. Some of these concepts are rooted in real observed physics, like time dilation and length contraction. They used to sound like sci-fi babble, but now we have measured them, built entire satellite systems that rely on them. Still, traveling faster than light raises all kinds of brain-breaking questions, like the causality paradox. What if your spaceship arrives before it leaves? Could you prevent your own launch? Erase your own lunch break? It is the kind of stuff that keeps physicists awake at night, scribbling equations and questioning reality itself. But instead of giving up, scientists are getting creative. New warp models are coming in hot. Ones that dodge those old problems by ditching classical thrust in favor of space-time manipulation. And here is the wild part. The original Alcubierre drive concept needed some seriously exotic fuel, matter with negative energy density. But new models are trimming the crazy and keeping the warp. Some do not even need exotic matter at all. Of course, we are still not ready to fold the universe like a blanket just yet. Most warp drive concepts right now have a few quirks. Think uncontrolled energy surges and ripping a hole in the space-time continuum kind of quirks. Not ideal for your morning commute to Alpha Centauri. That said, the energy around this field has never been higher. Rumor has it secret labs from NASA to SpaceX are working overtime on warp technologies behind closed doors. And honestly, would you be surprised? Here is what is really exciting. We are not just dreaming anymore. We are calculating, testing, revising. And out of all this ambition, 3 leading warp drive concepts have emerged. 3 models that take us beyond sci-fi and into the realm of actual science. The common thread, a complete rethink of how movement works. These models do not move a ship through space. They move space around the ship. Warp. It means to twist, to bend, to distort. And now it is the key to a concept that might let us break the universe's biggest speed limit without actually speeding at all. Instead of racing through space, what if space itself moved around us? That is not just a sci-fi dream anymore. It is becoming a scientific possibility. The idea is not new. Back in 1994, physicist Miguel Alcubierre proposed something that sounded straight out of Star Trek, a warp bubble that could carry a spaceship across the cosmos without the ship technically moving at all. Space would contract in front of the ship and expand behind it, creating a wave that propels the vessel forward. Kind of like surfing through space-time. The ship itself would remain stationary inside the bubble, dodging all the nasty side effects of relativity, like time dilation or infinite energy demands. But there was a catch, actually a pretty big one. Alcubierre's model relied on exotic matter, a strange type of energy with negative density that so far we have not found. It is like designing the perfect car, but needing fairy dust to run it. Still, the idea caught fire. Scientists started exploring variations like the Notario drive, a twist on Alcubierre's model that reimagines the geometry of space displacement. It is considered mathematically more stable, but there is still that pesky requirement for energy types we have not quite figured out how to produce yet. Then came something truly exciting. In 2021, Dr. Harold White, a NASA researcher and head of a propulsion lab in Texas, made a startling discovery. While studying quantum phenomena, specifically the Casimir effect, his team accidentally created a nano-sized warp bubble. Let that sink in. Theoretical warp geometry, not on paper, not in fiction, but in a real-world lab. Even better, White's updated calculations show that a warp bubble might not need infinite energy. With smart tweaks, the energy requirements drop dramatically from cosmic levels down to something like a few hundred kilograms of negative energy. Still exotic, but suddenly not so impossible. It was proof, however tiny, that warp fields could exist in nature. And if they exist on a microscopic scale, maybe, just maybe, we can scale them up. Meanwhile, in Germany, things got even more interesting. In 2024, a research team at the University of Potsdam simulated how space-time distortions like those created by a warp drive would appear in gravitational wave data. They are thinking, if alien civilizations have already cracked warp travel, maybe they left behind detectable space-time ripples. If we find those patterns, we might be able to reverse engineer the tech, learning from alien footprints without ever seeing the alien. So where does that leave us? Are we about to hop on a warp ship next week? Not quite, but the pace of discovery is incredible. More and more scientists, engineers, and even major space agencies are beginning to see space-time itself as a viable frontier to manipulate, not just fly through. And that changes everything. Because if space can be bent and shaped like fabric, then we are not just limited to building faster rockets. We are opening doors to things once considered magic, traveling to distant stars in days, not centuries, communicating across galaxies through warp channels, harnessing new kinds of energy, even accessing dimensions or states of reality we have never imagined. To me, this is the most exciting part. We aren't just figuring out a new way to commute. We're fundamentally redefining our relationship with the universe. Warp travel is no longer confined to the realm of fiction. It is becoming a very real possibility. And with each new breakthrough, we are not just learning how to explore space. We are learning how to reshape our future. Because maybe, just maybe, the road to the stars is not a road at all. Smash that like button before the aliens do.